All right, this recording is going to be about the first step of our information processing model, which would be encoding, getting information into the brain, and specifically how encoding matches up with Atkinson and Shiffrin's model. Their first step of how memory works talks more so about effortful processing, and specifically, their first step is going to be sensory memory. So here, we're going to look at sensory memory from a couple of different perspectives, but mainly we're going to be focusing on the capacity of sensory memory and how much information we can fit there, and also how long information lasts once it's in sensory memory. So looking at the definition of sensory memory, we see that it's that very, very brief, immediate recording of information. And the place that information is recorded is known, at least theoretically, as your sensory registers. So these are those entry points for raw information from the senses. Now I say theoretically, sort of metaphorically, you don't have an actual location where sensory memory is stored, but if you see this kind of in a textbook or on the AP exam, we're just talking about kind of where information goes from the external world into your memory system. Now, there was a guy who looked at how long information lasts in your sensory registers, his name being George Sperling. And he wanted to study specifically the rate of forgetting from your sensory registers. And so in order to do this, what he did was he designed an experiment. And in the experiment, participants were brought into his lab and they were shown a picture. And this picture was a matrix of letters. 9 different letters were presented in 3 rows. And he flashed this to his participants for about 1/20th of a second. And what he found was that if he asked them immediately after how many of those could they recall, they would maybe be able to recall approximately half of them. And so he thought, well, that doesn't seem like sensory memory is that good. But then he thought about it and he said, well, maybe the problem is it takes them too long to recall them immediately after. That by the time you've listed kind of 1 or 2 or 3 of them, the rest of them have already faded from your sensory registers. So he performed a separate experiment, and what he did was he showed them the same series of letters, but this time he had told them, I'm going to sound a tone right after you look at this picture. And it's either going to be a really high tone, a medium tone, or a low tone. If you hear a high tone, that means you're going to list for me the letters in row 1. If you hear a medium tone, row 2. If you hear a low tone, row 3. And so when he sounded the tone immediately following showing them the letters, he found that recall was close to 100% for the line they had been indicated to recall. And so this demonstrates that your sensory memory can capture a whole lot of information, but that information fades really, really quickly. Like I said, if the tone was sounded immediately, recall was 100. If you waited even 1 to 2 seconds, recall really declined and really plummeted because it wasn't very good because information had already faded.